If you're feeling a little disoriented right now after realizing that now doesn't exist out in the universe, well, don't worry, it gets weirder. Now might not even exist inside your own brain. How did I do that? When we see a ball or anything, it takes 10 to 50 milliseconds for information from the eye to reach the brain, another 100 or so milliseconds before we can take actions on the basis of that information. During that time, the ball continues to move. So it seems like the brain's information about where the ball is will always lag behind where the ball actually is. So how are we able to catch the ball? Well, maybe our brains guess ahead where the ball will be. Maybe we use the information from the past to predict the present. Well, it's not quite as simple as that at all. Keep your eyes focused on the X. As the ring moves, a white circle flashes. What most people perceive is that the flash lags slightly behind the ring. But if we freeze at the instant of the flash, the white circle is actually completely inside of the ring. This is the flash lag illusion. Why does our brain see this? Well, thinking back to catching a ball, it fits with what we might expect, that our brain is predicting where it thinks the ring will be, that we are living in the past and our brain is guessing ahead. But this isn't what's happening. Psychologist David Eagleman set up a modified version of this experiment. Everything leading up to and including the flash is the same, but what happens after the flash changes. The ring either continues around, stops, or reverses. And here is what people see. Again, everything leading up to the flash is the same as the original experiment. If we were really using the past motion of the ring to predict its future motion, we'd expect the same result as our original experiment. Our brains putting the ring ahead of the flash. But that isn't what we see. What we perceive at the moment of the flash depends on what happens in the future of the flash. This is really strange. It means that the moment our brain calls now depends on information from the future. You know, this is starting to sound like we're time travelers or something. A better way to look at it is that there is physical time out in the world, and there's time that we make up in our brains. And when something happens on each timeline, doesn't match. Out in the world, an event occurs, then some other stuff happens shortly after it. Our brains take the stuff that happened just after and combine it with the event itself to create a single moment in our heads, a now that doesn't exist in the real world. It's what Eagleman calls the illusory present. So in a very real way, we do live in the past. When this moment, when now occurs, it's already happened. For experiences like the flash lag illusion, each of us lives in our own now that is 80 to 100 milliseconds in the past of the now in the universe outside our skulls. But why does this happen? Well, because the brain is surprisingly slow at processing information that comes in. I mean, different signals arrive at the brain at different speeds and different times, and they have to be decoded and processed in different regions of the brain before we can have a conscious experience. You see the world a lot like Saturday Night Live. I mean, it seems like what we're seeing is now, but really there's a delay built in to what we can see. Only it's not in case someone says a bad word or has a wardrobe malfunction. It's because of all the information from different senses and places reaching our brain at different times. And our brain having to decide which bits of that information happened at the same time. I mean, it feels like all of our senses across our body are unified. That what we hear and what we feel and what we see are all in sync. But this is a feeling created in our brain. And there's a really simple way to demonstrate this. Just touch your nose and touch your foot at the same time. I mean, I feel those as simultaneous, but I mean, the signal from my foot took many milliseconds longer to reach my brain than the signal from my nose just by the sheer distance. But your brain waits and takes all of these signals arriving from the past and like a video editor, syncs them up and creates a conscious experience where they happen simultaneously. This also means that tall people like me live farther in the past than short people. Scientists once tested sprinters to see if the sound from a starter pistol or a flash of light would get them off the line faster. I mean, light travels more quickly than sound, so you would expect a flash works better. But they were actually faster in response to the sound, because auditory signals are processed faster than visual signals in our brain. But if that's the case, I mean, why does that work? I mean, the movement of my hands and the sound appear synced, even though the hearing part of my brain gets the signal before the seeing part of my brain. In the early days of TV broadcasting, engineers were worried about how to keep the sound and picture in sync. You see, unlike film, where the soundtrack is physically linked and printed on the film strip, TV broadcasts use separate signals for sound and picture. And it turned out they didn't need to be in sync, at least not perfectly. As long as the sound and picture weren't more than 80 milliseconds out of sync, people's brains made the correction for them. Just like yours have been doing. The sound and picture have been out of sync for the last several seconds, and I bet you didn't even notice. But if I walk away at a certain distance, your brain decides the sight and sound are out of sync. That distance is about 100 feet or 30 meters. Because it's the distance at which the speed of light and the speed of sound reach you more than 80 milliseconds apart. Here's another weirdness. Our eyes make small jumps several times a second, movements called saccades. If you stand close to a mirror and look back and forth between your right and left eye, someone watching you will see your eyes move back and forth, but you won't. Our visual system just turns off when our eyes jump from spot to spot. Otherwise, the world would just look constantly blurry. But we never notice these gaps in time because our brain uses the past to fill in the now. You should try this. It's seriously trippy. Your brain is not a clock that tracks time. Time is actively constructed by the brain. And whether it's in our brains or out in space, now is not a place, because time is not a map with coordinates that we all agree on. Time is just a way to measure change, and change can happen at very different speeds for any two people. There's nothing in the laws of physics or even our own brains that says there is one single now. I mean, the universe is a stranger place than most of us realize. Thanks for joining me in this moment, whenever it is, to learn a bit more about it.